Okay, so today's Friday, and today we'll discuss uh, the different ways that a bipolar junction transistor is used in uh, electronics. There are basically three circuits. We'll go through those. But also, you yesterday took the exam. I will have, I'll grade that over the weekend and send you something either on the weekend or by Monday. You'll know how well you did. Um, I'm thinking most of you did, did just fine. Okay. So, what are we going to do today? Well, there are, uh, the bipolar junction transistor is made up of three parts. Okay. There's an emitter, there's a base, and there's a collector. And basically, as we were told yesterday, the bipolar junction transistor is basically uh, two diodes that are back to back, where one diode is forward biased and the other diode is reverse biased. Okay, so that is the bipolar junction transistor, and it gets its names and its process from the earlier version of the vacuum tube technology uh, component. So, what did the vacuum technology component do? Well, it actually was able to increase the current. Okay, so you got a boosted current because a signal that you got from a radio signal that you got is weak. Okay, it's a weak signal. It's picked up, induced in a wire antenna. Okay, and we can boost the voltage by just simply passing it through a transformer, and you all know how to do that. But that just increases the voltage, and to get increased power, we also have to increase current. And the way the current is boosted in the case of a vacuum tube is first we pass the current that's picked up from the antenna and the higher voltage through the transformer, pass that current through a filament. Okay, so the first part of the vacuum tube is the filament that carries the current that's been picked up. Okay, beyond that, or next to that, is a grid, and the purpose of that grid is to place a high voltage potential on the grid. And what the function of that is strips electrons off of that filament, that conducting filament, and makes them accelerate through the grid. Okay, so the higher the potential, the faster that streaming electron travels, and is finally uh, impinged onto a collector plate. So you've got the collector plate, you've got the emitter filament, and you've got the grid potential, high potential grid. So by increasing that voltage, essentially gets you a much higher current. So now you've got a higher current and you've boosted the voltage. The two together will increase the power. So the power is increased, and you've boosted from a uh, low voltage, low current signal to a higher power signal that's good enough to be heard well on some of your speakers systems. All right. So today, though, we will talk about, okay, we've got a transistor, a bipolar junction transistor, which essentially is made up of three sections. So there are three wires. And what we want to do with that is we take an input, boost it to get an output. Okay, so that's all we need is two wires. We need a wire for an input and a wire for an output. But we have 3 wires in the transistor. So normally what we do is we have a common usage of 2 of the wires. All right. And because of that, then we have 3 circuits that are used in the case of bipolar junction transistors. Okay, these are the common base, the common emitter, and the common collector. Okay, and each has different properties. Okay, in each case, we either boost current or voltage, maybe both. In one case, we don't boost, but we actually allow the voltage to be steady. Okay, and that particular circuit is called a voltage follower, so that we can feed that so to get a common voltage that doesn't change. All right. So I will have your scores over the weekend, and I'll get you them over the weekend. No later than Monday. Anyway, you'll all know how you did. All right. So let's get going.